Alright. So, a lot of times we can take stats. And we see a lot of tables in algebra and in math, right? A lot of times we're looking for stats out of a table. Quite frequently, if they give you, or they're trying to do stats as percentages, you see it as a circle graph, right? A circle graph, which used to be known as a pie chart. Those are both exactly the same thing. One new name, one old name. Let's see, you guys mentioned a bar graph. A bar graph is similar, but not exactly like a histogram. Let's see, what else did you mention? You mentioned a line graph. Yep. A dot graph, which really is kind of like a frequency table. So I'll put frequency up here. What else? Oh, yep, stem and leaf that we're going to do today. Stem and leaf. Ooh, L-E-A. That was supposed to be an A in the middle. Let's see, we also mentioned a box plot. And the other one, if we get time, we're going to get to a time graph. Lots of different ways we can represent data. Some ways are easier to use than others. Alright. So, in the process of all of these, the reason we put them into tables is because depending on what the data is, we want to be able to quickly look at it and interpret it. So, before we keep going, one of the things I want to talk about is distribution. And some of the ways we describe the distribution. So what the distribution, that's a T there in the middle, what the distribution is the shape of the data. So, for example, one of the words we use to describe it is unimodal. That just means if it's uni, it's got like one grouping of data. So quite frequently, if you have this like data looks like this, a lot of times it kind of looks like you have most of the stuff all together, right? Bimodal, but you can probably guess what that looks like. It's got two groups in there, right? Doesn't all kind of fit together. So maybe that has like a lot in the beginning and a lot at the end, right? So here it's all there. We also can use the word symmetrical. When I say symmetric to describe the distribution, that means that each side or the two sides are even. Each side is similar to the other, we'll say. So again, that might look like something like this. So you're saying that this side and that side are very close. When you're talking about data, the perfect data looks like that, where the two sides are even. And the middle of the road is supposed to be where most of the data is. That's when some of your teachers curve your tests and stuff, right? They say this is supposed to be where most of the C's are, a majority of the class. And then you go left to the A's and left to the E's. That's how it's supposed to work. Let's see what other words you got. Oh, these are the two tough ones, and these are the ones you probably are going to see the most. So I'm going to put a little star here. I'm going to say skewed right and skewed SK. If it lets me right. Come on. Skewed left. Now, the reason I say these are tougher is because it says skewed right, but what that really means is most of the data is on the left. So if it says skewed left, that means most of the data is on the right. So, for example, if you got a data that looks like this. You see most of the data is more on the left-hand side, right? We would say this is, got most of the stuff all together. We could say this is unimodal. There we go. And we would say this is skewed. It's skewed to the right. Most of the data is on the left, so you say skewed right. Because you want it, the reason they do it that way is it's like saying it should be more to the right for it to be legitimate data. So you want to like pull it to the right, so skewed right. Okay, does that make sense? It's very backward. So if most of the data was over here on the right hand side, we'd say it was skewed left. Okay? Alright, so now we talked about that. Let's get into some things that you might see today and how you're going to work them out. Alright, here we go with example number 1. We're going to start off with an easy one. They're going to give you a table. So let me throw a table up here. Yeah, it's going to be a lot of writing today, unfortunately. This is going to be a table about people watching the Super Bowl, okay? So, you know, there's men and women that watch the Super Bowl. I'm going to have a total column. People watch the Super Bowl for lots of reasons, right? Some of them watch it to actually watch the game. Some watch the Super Bowl for the commercials, of course. And some don't watch. Alright. We're going to fill this table in. So what they're saying is we've gone out and we randomly talked to all these people, just walked up to somebody standing in front of McDonald's and said, why do you watch the Super Bowl? And they gave you your answer. You're filling in the data. Okay? So in this table, we're going to say that we have 279 men watch the game. Out of those that were randomly polled, 200 even, we'll say 200 women watched the game, which gives us a total of 479 people that watched the game. Next line, for the commercials, 81 men said they watched the game for the commercials, 156 women, which gives us a total of 237. Out of the ones polled, we have 132 that don't watch. We have 160 women that don't watch. And we have 292 total out of the ones that don't watch. So we have this total column this way, and let's do a total column this way. So if we were to add up all the men, we have a total of 492 men. If we were to add up all the women, we have a total of 516 women. So if we did our totals right, the columns this way and the columns this way should be the same, right? Totals, which I have 1,008. So hopefully I added this correctly. Here's our table. So your first couple questions in your homework, they're giving you a table similar to this, and they're going to ask you questions. Alright, so let me give you a question. Question A, what percent I better make sure I say this right. What percent of people plan to skip the game? Alright, so if we're talking people, we need a total, right? Which means all the people that don't watch is a total of 292. Out of the total number of people, which is 1,008 that we polled. So today it's going to ask you for percentages. I think I got 28.97. Let's round that to 29%. Just for giggles. Alright, so I'm going to change this question up just a little bit. Just a little, and how the wording is going to change your percentage. In this one, I'm going to say what percent of people, were men who planned to skip. Alright, so out of this group, you're right, we're taking 132 out of how many? Okay, so right here is the key. It says of people. If I said of all the men, we take the 492 because that's all the men. But we need to take into consideration all of the people. So what should my denominator be? The total, 1,008, right? So go ahead and divide that. Give me a percentage.
13.1%.
Thank you. 13.1%. Thank you very much. All right, I'm going to try and move this up a little bit without losing too much of my table here. All right. Question C. We're going to change it even a little bit more. What percent of the men plan to skip? How does that change my fraction? Correct. Very good. Yeah, 132 out of the 492. What did you say it was, Michael?
26.8%.
Thank you. 26.8%. All right, now here's my last one. Just going to change it up just a little bit more. What percent of the people who skip the game move it up, I want to come back to numbers. Skip the game were men. All right. So now we're talking about all the people. How many were, huh? Oh, not quite. 292, yes. So all of the people are right here, right? But we've got to use this column. We're actually taking the 132 and divided by 292. So this is 132 divided by 292, and that percent?
45.2%.
Thank you. All right, so depending on how it's written, because every one of those, they're very close, but what you're trying to find the percent of changes a little bit. Cool, be appropriate. All right. So try, is there any questions on this or filling in this table? Okay. So then let's try changing this a little bit. What if we needed to fill in the table ourselves? Let's do example number 2. Whew, I'm not going to get very far today. I'm so disappointed. Alright, so this one, we're going to complete the table. Let's say in my table, maybe we have success, I don't know, fail. My last column, of course, is my total. Let's say you hit left-handed, you hit right-handed, and we have a total down here. Alright, so if in my total, the total left-handers were 48, total right-handers are 192, and it's out of 240. Then total successes are 210, and total fails are 30. We need to find these 4 numbers. Okay? So I'm going to kind of label this A, this one B, this one C, and this one D. Alright, so let's talk about the section A first. In order to figure out what A is, we have to find a percent of what the total is. So the easiest thing to do is to find A. We are going to take, of course, what's across from A, which is 48, divide by the total, which is 240. That's going to give me a percent of what we have that will fall there. Okay? So in this case, I think that percent is 20%, right? Or 0.2. So 20% of it's going to fall here, and it's out of this success of 210. So now I'm going to take this 0.2 and times by 210. So 0.2 times 210 should give us 42. That's going to go in this spot right here. So now to find B, we can either subtract it from 210, or we can do that same process again. So to find B, we can either subtract, or we can take 192, divide by 240. It should give us 0.8, and then times by, again, 210. And we get 168. So this would be 168. So, yeah, and then you can either subtract to go across, so this would be 6, right? And then this one would be 24, thank you. Okay, so once you find 1, you're right, you can subtract this way and subtract this way. Or you can use your percentages to find out 4. It's up to you. Okay? Do you have a couple of questions like that? Everybody good there? All right. Let's go to example number 3. Let's talk about a stem plot. So, when we talk about stem plots, there's 2 different types, and I know you guys have seen these before. There are one-sided and two-sided. What you usually do when you talk about a stem plot, and I'm going to do a one-sided one, you have a small thin column first, and then in this thin column, either, depending on what numbers you're using, this might be your tens column, right? So if this is your tens column, you'd have 0, 1, 2, 3, 4, 5, and so on. So then when you're going through your data, and let's say you get something that's a 12, you actually, across from the 1, you just put the 2. Right? And maybe in my data, I have a 53. Then across from the 5, I put a 3. Maybe I have a 54, then I put a 4 here. So all of these represent the data, but you're only writing the tens column once. Does that make sense? Yes? Okay. So, with that in mind, you can see how once you put all the data here, this is our stem. This is kind of like used to be called leaf, stem and leaf plot. Oh, okay. So let's just do one. I think that'll be easier. Here's example number 3. So I've got to give you like a ton of data to begin with. I know that's not fun, but so I want you to make a stem plot. And I'm going to give you some data. Let's say, over time, McDee's sold burgers, and my table is going to be in billions. Alright, so, in my data here, I'm going to say in 1968, we have 1.4. 1970, maybe we have 1.8. It's a 1.8 billion burgers. In 1972, we have 2.4. In 1974, we have, let's go with, I don't know, 1.7. 1976, we have 2.2. 1978, let's go up to, let's say, 3.2. 1980, say we have 4.1. 1982, burger must have been expensive because we only have 2.8. 1984, let's say they only sold 4.3 billion. 1986, 4.9 billion. 1988, it goes back down to 3.8 billion. 1990, let's say our data is 5.6. 1992, I'll just do a couple more. 5.1. 1994, 7.9. and 1996. Let's say it went back down to 5.5 billion burgers sold. Okay, so here's all our data. And again, all that's going to be in the tables in your book. Alright? So, you can see that they all start with like single digits and then a decimal. So when we do our stem is going to be your single unit. Okay? So in here, we're going to start at 0, 1, 2, 3, 4, 5, 6, and 7. Do we have anything higher than 7? Nope. Okay. So now we're going to start at the very beginning of our data, and we have 1.4. So across from 1, we're going to put a 4. Then after the 1.4, we have 1.8. So I'm going to put an 8 next to the 1. Next one, we have 2.4. So I'll go down to the 2 and put a 4. Then I have 1.7. So I'm going to come back up here, and I want these to try and stay in order. So you'll notice I'm going to squeeze 7 between 4 and 8. Okay? I have 2.2. So where the 2 is, I'm going to put my 2 here. I have 3.2, 4.1, 2.8. So I'm going to come out here and put my 8. Then going back up at the top, we have 4.3 and 4.9. We have a 3 and a 9, right? We then have 3.8 and 5.6. So back here, 3.8, 5.6, 5.1, 7.8, and 5.5. Alright, so we have 3 pieces of data here, 3 pieces of data here, 2 here, 3 here, 3 here, none in 6, and 1 in 7. So the idea behind making one of these is so you can see how spread out it is. Maybe it's all unimodal, maybe it's symmetrical. Also, the other thing is there an outlier? Yeah, oops, I didn't spell it there. I don't know why I put next G. There we go. Yes, there is an outlier in this case. So 7.8, right? That's going to change. If we were to find the mean, the average, anything like that, that 7.8 is going to change it. That's one of the things we use the stem and leaf plot for. So I think I'm going to stop after that, which means I'm obviously changing that, since we haven't had a chance to get to frequency or histogram or anything. And it's already 4 minutes after, 3 minutes after. So, your assignment, I'm going to change it to, let's go 2 to 14 even. I know you're heartbroken about it, right? 2 to 14 even.